Hi, in this tutorial we will solve the following exercises. So for exercise number 1, we have the following set of functional dependencies that is given, which is this. And given that set, we will answer if these functional dependencies can be derived from that set. So for exercise A, we will do the following. Can F logically imply this? So the best way to solve this is to get the A plus. So for the A plus, we do A, and then A implies B. So now, if C is a subset of A plus, then the answer is yes. The other way is that we can use Armstrong's axioms, but that takes a little longer, so this is easier. So now, once we got AB can get C, and actually we can answer now the question because C is a subset, so then we say yes. We don't really care about the AB plus, but as soon as we see that this attribute is a subset of the closure, that means I can be derived using those sets. Okay, I will uh, fold the paper, answer the exercises we have here. So we got answer for A, so now let's get the answer for B, and let's do the same. Can F logically imply this? So we get the B plus, so we got the B, getting the B, we don't get anything else, so the answer is no. Now for C, can set F can logically imply that A and D get D and E. So then we could got the AD plus, which is AD. Getting A, we can get B. Getting A and B, we get C. And getting BCD, we get E. So DE is a subset of AD, so the answer here is yes. Now let's solve exercise D. So now for exercise D, we don't even need to check that on the set F. So here if I go to second F, logically imply that. So we don't need that because we can see that CD is a subset of this side. So then the answer here is yes. This is what we call a trivial dependency. Now for E, we got that CDE from F. Can that imply this? So then we need CDE plus, and this is CDE, and there is nothing else that we can derive from there. Then here the answer is no. And then finally, we can answer question F. And for question F, can F logically imply that CD derives CE? So we need the CD plus, which starts with initial value of CD, and we see that there is nothing else that can derive from CD, so CE is not a subset of CD plus, so the answer here is no. So we got all answers for question number 1. So now let's work on question number 2. So for question number 2, we need initially, so question 2 for A, we need the closures for A, B, C, D, and E. So let's do A, B, C, D, and E. So we need the closure. So we know that the initial value for each one of those is this. And then we're going to check what else can we be derived from A using this set. So we see that we got the B. Once we got the A, B, we got the C. And A, B, C, B, C, we got the D. see D, we get the E, and we're getting all the attributes of R. So A plus is a key. A is a key. So now B plus, there is nothing else that can be derived from B. C plus is the same, nothing else. D plus is just D, and E plus, we get the A, and we know that once we got the A, we got everything else, so it's actually the same as A plus. So we got A, B, C, D, and E. Now for the next question, list candidate keys. Well, we can do that here. Here, let's put the B here. So we can see that A is a candidate key, that E is a candidate key. So now we need to check if the B, the C, and the D, the combinations of them are also candidate keys. So, for example, here we see that E can be derived using C and D, and E is a key, and C by itself is not a key, and D by itself is not a key. Then CD is also a key, candidate key. Then we also see the BC derives the D, and once we get the D with the C, we can get anything else. So then also the BC. So we got the B and the C, and the C and the D. And then that's it. Now, the last question is list all prime attributes. So the prime attributes will be the elements of the keys that are keys. So for example, the A, the B, the C, the D, and E, because they are all part of the key. Okay, so we're done with question number 2. Let's now work on question number 3. Now for question number 3, we have the following table, and we need to answer if either one of those can be functional dependencies over this instance, if that is possible. So what I will do is I will have here A, B, C, D, E, F, G, and H. So we need to write yeses or no for each one of those. So let's go with the first one. Can A imply B? So let's see. We got A1, A2, A3, A2. So here we need to check the ones in the ones that are equal. So A2 and A2. So we got B2 and B2. So when it's A2, B2, so there is no contradiction. It's the same. So for A, the answer is yes. For B, A, C, let's see A, C. So we're checking the ones that are equal. A2 and C gets C1. A2 on C gets C2. So there are two different values. So here, for that reason, is no. Then on C, B implies C. So we check the ones that are equal. So we got a B1 and a B1. When it's B1, we got a C1 and then a C2. So the answer is no. For D, A and B together. So let's see. A and B, so A1, B1, A2, B2. So here we got two that are the same. A2, B2. We look for the ones that are the same. A2, B2, A2, B2. So here is C1, C2. I got two possible values. So that's wrong. So for D is a no. For E, can A and B imply A? This is actually trivial. Look, A is a subset of AB, so we don't even need to check. So the answer for E is yes. Now for F, can C determine A? So let's see, we check for the ones that are equal, C1, C1, and we got two values for A's. So the answer for F is no. Now we check on G. A and C together determine B. So let's see, A and C, we got A1 C1, A2 C1, E3, so A2 C2. So we got all distinct values for the combination of AC. Then the answer will be yes. You don't need even to check the other side. Now for H, can B and C determine A and C? So look at that, we got the C and the C there, right? So it's basically getting if B, let's see, B, C, B and C, and see we got any distinct value. So B1, here is a B1, and when we got the B1, we got the C1 and the C2, B2, and B2, they got two different values. So the combination of BC gives me all distinct values in this side. I don't even need to check the other side. So for H, we say then yes. Okay, so we will continue with the other set of exercises in the following tutorial. Thank you.